Hi, and welcome to Module 2 of A Brief Introduction to Game Theory. In this module, we're going to discuss two things: preferences over outcomes, and the assumptions that underlie rational choice. We're also going to discuss utilities, which follows from, in this case, rational choice. So, what are preferences? Preferences here are just what one prefers in terms of outcomes, what the actors want, which outcomes they like better, which outcomes they like worse. It's natural at this point to wonder why preferences weren't put in the previous module's building blocks discussion. And they could be. In game theory, preferences are absolutely foundational. They are a building block of game theory, and it would be completely fine to have put them in the previous module and discussed in that context. The only reason I didn't is because I wanted the building blocks to apply to more than just game theory, and you can think of other theories in which you don't need to assign preferences. Maybe people were to respond to stimuli and take an action that's codified by some stimulus, like say a computer would do, and because that response is just a stimulus-response interaction, you don't need preferences to get used in the model to help us understand what actions are taken. The actions you take are determined by your preset response to the stimulus. That's why that's kept separate, because you can imagine models of behavior that don't include preferences. All that said, game theory does include preferences, and from now on we're going to be talking only about preferences as foundational. So, what are preferences in game theory terms here? Let's start by talking about three discrete outcomes. I'm going to call them, in the notation we did last time, x, y, and z, and we're going to say they're all elements in some big set x. Remember that big set X was some outcome set. It contained all the possible outcomes that could happen. And X, Y, and Z were elements of this outcome set. Okay. So I should say, if I want to be a little more general, I could have put X sub I here last time. That would refer to outcomes if they differ for individual people. Usually most of the outcomes we're going to be dealing with here are numeric in a sense, that they're numbers, right? And they're the same for every actor. But you could think of more abstractly outcomes that might be specific to particular individuals before I get assigned some number. So, winning a job in some competition might be an outcome that could be different for you than for someone else who's not possibly getting that particular job because they didn't even apply for it or whatever. Okay. That said, X, Y, and Z are outcomes that could happen to some actor I. What does it mean to prefer one outcome to another? Well, we can write x r y, which is read x is at least as good as y. So I like x at least as good as y. Or I like x at least as much as I like y. If I want to be explicit, I can make sure I put a little sub I here, which means actor I likes x at least as much as actor I likes y. So that gives us a sense of sort of a greater than or equal to relationship, right? Like, if I had a choice between x and y, I would choose x as much as y and possibly more. I would never potentially choose y and discard all possibility of choosing x because I like x at least as much as y. If you want to be a little more firm about it, we can say x p sub I y. That means I like x strictly better than y. I prefer x to y strictly. I would always choose x over y if given the choice. I might have things to someone different, so I might have x I y, and that means I'm indifferent between x and y. Now, indifference here has a very specific meaning. It's not I'm not sure. It's I literally am indifferent. If you gave me a choice between x and y, I would not care which one I got. I am completely indifferent between those two things. It's like saying, if you give me these two quarters versus those two quarters, which one do I like better? I don't care. True indifference is actually not super common, right? You might imagine, well, the two quarters are the same in both cases, but that quarter is one of those 50 state quarters, and I like those quarters, I'm collecting them or whatever. It doesn't matter. Point is, I might have some reason to prefer one to the other. Maybe I'm comparing 50 cents in quarters to 5 dimes. I prefer the quarters slightly because I can do my laundry. all these things could go into your decision process, but if I were truly indifferent between x and y, I could say x, I, y, which means I'm indifferent between x and y. These are core preferences. You can have preferences over anything you want. Right? And we assume actors have preferences. Now, in order to go about using game theory, we have to make certain simplifying assumptions on preferences, so not everything is possible. For most of game theory, we're going to be assuming what's called rational choice assumptions. Rational choice means something very specific. You might have seen it, the phrase used in a different course in some context, particularly if you've studied any political science or economics. Oftentimes, rational choice isn't used very accurately, but it does mean something very specific. What it means is these two bullet points that follow it. First, it means your preferences are constrained in a particular way. The first element of this is that your preferences are complete. Complete preferences mean for any two outcomes that I might achieve in this interaction, this choice I am making, I know how to rank order them via preferences. I can tell you, is x at least as good as y? Is x better than y? Or am I different between x and y? Or is y at least as good as x? More formally, for every x and y, I can write either x is at least as good as y, or y is at least as good as x. If my preferences are complete, then I can tell you which of x and y is a sort of preferred option for any x and y. That means there can't be any outcomes that I could achieve for which I am actually not sure. Now, that's a reasonably strong assumption for a lot of things. There's a ton of stuff I can tell you about myself, but if you gave me a choice, I would have no idea what choice to make. I would think about it a lot, maybe do some research. That's not true here. We're assuming for rational choice that for every outcome in this interaction, in these games that we're going to play and talk about, that for every possible outcome, you can rank order them. You can tell me which one you prefer. Those are complete preferences, and we're going to assume that for most of what we do. The second assumption is called transitive preferences. Now, if you haven't seen this before, it looks like this. Let's say I know that x is at least as good as y, and I know that y is at least as good as z. So, I think x is at least as good as y, and y is at least as good as z. If my preferences are transitive, then, given these two things, I know also that x is at least as good as z. So if, in sort of more common terms, if I like x better than y, and y better than z, I better also like x better than z. Why is that? Let's say I didn't. Let's say instead, I like x better than y, and y better than z, but I like z better than x instead, right? What does that mean in this case? It would mean instead of x or z, the opposite of that is I like z strictly better than x. Let's say instead I like z strictly better than x. Well then, if I like x better than y, and I have x, and you have y and I have x. If you have x and I have y, I will trade you my y for your x. Now, the same token, if I have z and you have y, I would trade you my z for your y. So how does this work in sequence? Well, let's say I start with z. I find someone and I acquire a y from them. Now I have a y. I find someone else and acquire an x from them. So far it's fine. But I find the third person who has my original z, and I want that z back again because I like z better than x strictly. Now if I strictly like z better than x, I'll probably be okay trading my x for the z and maybe even giving them like a penny for it because I like z better than x, right? It's not even possibly equal. I like it better. So maybe I give them my x and a penny for the z. But what's happened now? I have my original z back again and I've lost a penny. This is what economists call a money pump. Basically, people can go around and take advantage of my non-transitive preferences and keep extracting money from me as I constantly reacquire my original thing by spending extra money. So we don't think this kind of preference is typically rational at the individual level, because why would I do that, right? If I knew ahead of time that I like Z better than X, why would I trade my Z away knowing that I'll just end up with an X that I like less? That seems like a bad idea. Surely I should recognize that just because there's a Y in the middle there, it doesn't mess up all my other interactions. It doesn't mess up all my other choices. So for transitive preferences, we say that if X is at least as good as Y, and Y is at least as good as Z, then, this is an imply sign, X is at least as good as Z. So we prevent this sort of money pump from happening. So the first bullet point for rational choice is everyone's preferences are all complete and transitive. So for any two things, I can compare them. For any two outcomes, I can compare them. And the preferences I get from these comparisons are always transitive. That's the first element of rational choice. The second element of rational choice is I can choose actions that produce my most preferred outcome given constraints. So if I know what I want, that's the first bullet point, and you give me some situation that I can try to take action to achieve what I want, I can choose the thing that gives me the best outcome. At a simple level, it's straightforward, right? If I have X, Y, and Z in front of me in a pile, and I know I like the X the best, then the rational choice says I will pick my X. I won't pick Z or Y, I'll pick X, because that's the one I like the best. That's sort of simple level. But for more complex situations, that means I can figure out the interaction, the system that I'm in, and do the thing that gives me my preferred outcomes in expectation. I'll get to what expectation means very shortly. It's that fourth bullet point there. But what it means is I can do the right thing. I can do the optimal thing. I can optimize what I do to achieve in terms of my preferences. That's a very strong assumption. There are all sorts of things in which you just can't do that. The modal example is chess. Chess is a game in which I have very clear preferences. I want to win, usually, right? I want to win the game. I can't get my optimal outcome. I can't necessarily even know what to do at a given moment to secure a tie. Contrast this with like tic-tac-toe, a much simpler game, in which I know how to secure a tie. I can always secure a tie from the beginning of the game. But I can't do that in chess. I don't have the ability to reason through all the possible outcomes in the game and secure an outcome and secure every outcome I wanted. Go is like that as well. It's even more complicated, right? So instead of being rational when facing a game of chess or Go, I have to use heuristics. I have to use rules of thumb to try to figure out what to do. Lots of decisions in real life we encounter and do not behave rationally because they are too complex or because we just don't care enough to do that. We'll discuss this in more length at a later module. However, for now, we're going to assume that people are rational and can always choose the actions that optimize the outcomes for them. Okay. Now that's a little fuzzy, so what we're going to do is we're going to put our preferences into a more concrete form that makes it easier for us to figure out what it means to act rationally. And the first thing we're going to define is utility. A utility is just a numerical representation of our preferences. So what we do is we say the utility, it's a function, the utility of some outcome x is going to be greater than or equal to the utility of some outcome y if and only if we like x at least as much as y. So what does that mean again in English? It means if I like x at least as much as y, then my utility for x, that's that u of x in the beginning, is greater than or equal to my utility for y. So I'm translating my preference orderings, that x is at least as good as y, to my utilities. which are just numbers. U of x takes whatever x is. It could be an apple. It could be a job. Doesn't matter what it is. It's a thing. It's an outcome that you could achieve. You could choose or get through some more complicated interaction. And it assigns a number to that, a real number to that. So by comparing these real numbers, I can tell you which I like better, x or y. In this case, I like x at least as much as y. So my utility for x is greater than or equal to y. If I like x strictly better than y, then my utility for x would be greater than my utility for y. If instead I like x the same as y, if I are indifferent between x and y, then my utilities would be equal. So basically I'm translating a kind of abstract preference ordering that can get confusing and difficult to manage into very clear utilities. And in this context, it's really simple to figure out what rationality means. It means I do the thing that gets me the highest utility. Period. And why is that helpful? We won't do it in this class at all, but if you go on in game theory, what you'll see is you can maximize your utility function, which you can do by using calculus often, sometimes just by comparing numbers, and you can choose a thing that gives you the highest utility. We'll be doing that part without calculus as the course goes on. We'll just be choosing the things that give each actor their highest utilities, given what other actors are going to do. More on that though in the next module. For this, we have to deal with one more case before closing, which is what happens if things aren't always so certain, right? So far, we've been dealing with x, y, and z and saying, well, I like x better than y, so, my utility for x is better than y, so I should choose x. Cool. What happens, though, if things are uncertain? What if I'm playing a lottery? A lottery in common usage is just a thing you pay like $1 for it, right, and you get some numbers and you see if the numbers are drawn. A lottery in economic terms is just, in game theory terms, is any random possibilities assigned to a series of outcomes. So if I have a, say, 0.5 chance of getting x and a 0.5 chance of getting y, given some action I take, that's a lottery over x and y, in which the chances are equal. If instead I have a 0.7 chance, so a 70% chance of getting x, and a 30% chance of getting y, that's a different lottery over x and y. So, how do I use this? Well, what I can do is I can figure out how to convert a lottery to what's called an expected utility. It's the utility I expect to get if I were to play this lottery. And for discrete outcomes, it's relatively simple, and I'll write it here. The expected utility is called EU for expected utility of some, let's call it lottery L, just to call it lottery, is equal, and let's say there are only two possible outcomes in this lottery, x and y. Well, it's equal to the chance that you got x times my utility for x plus the chance I get y times my utility for y. That's it. So if, for instance, for example, I have utility exactly equal to the money I would get, and let's say if the outcome x is I win $1, the outcome y is I win nothing. Then my utility for x is 1, and my utility for y is 0. Then my expected utility would be the probability I get the 1 outcome times 1 plus the probability I don't get the 1 outcome. Let's say there's only 2 outcomes, so it's 1 minus p times 0, which is just p. So my expected utility would be increasing the higher the chance is I get the 1, which makes sense. You can do this more generally for much more complicated utilities. You can do it for continuous outcomes as well. We're not going to do any of that stuff. Instead, we're just going to focus on the idea that we can convert any kind of outcome, whether they be certain or uncertain, into a concrete number known as expected utility, and then compare expected utilities. So if I like lottery 1 more than lottery 2, then I say my expected utility for lottery 1 is greater than or equal to my expected utility for lottery too. So you can compare them in the same ways. So now there's more math here. You might like, there'll be less in the future modules, but the reason I'm including this is to give you a sense of what's really going on here, and it's not so much. All I'm really saying is you can translate complicated preferences, once you assume rational choice preferences, you're rational in your behavior, into utilities and expected utilities that are just numbers, and compare these directly to figure out the thing that gives you the best outcome, that gives you the optimum thing you can achieve, given the constraints. So in this case, if I have two lotteries I have a choice over, I can pick a lottery that gives me the best expected utility. As we'll see next time, in the next module, this gets complicated when other people are involved because their actions might constrain your possibilities of getting your best outcomes. Maybe, for instance, as we'll see next time, you could get a very good outcome if you cooperated, if they cooperated too, but if they're not willing to cooperate, you can't get that outcome. So it doesn't matter to you, in that case, that you could get a good outcome if they cooperated, because they're not cooperating. They're constraining your behavior. That said, you're still rational as long as you seek the best outcome you can get given those constraints. And this conceptualization of utilities and expected utilities lets you put a nice number on your preferences over outcomes so you can compare what it's worth to you to get different outcomes or to get different lotteries over outcomes. That's it for now. Next time we're going to move on to actual game theory. This often is called decision theory if you treat only one person at a time because you're trying to find the best decision you can make. Thank you.